So our next speaker is Hans, from a company I'm very familiar with, actually. So Hans, this is your slide.
All right. So I'm Hans. First, I'm at MPLS, so I'm very excited. In this presentation, I'm going to talk about operation efficiency across the IP and the optical layer. So the way I've built up the slide deck, in the first part, I will give a little bit of an overview of how the status is today with many of the operators. Then I'll explain a little bit what the possible use cases are that IP optical coordination could bring. And I'll explain them a little bit more in detail going further down in the slides. So if you look at the IP optical space, it's a very unique space and historically has always been hit by operational silos, I would say. So an evolution of that and a breakdown of that silos is really required in order to bring efficiency improvements into the operation of the network between the IP and the optical layer. If you look at today, the operators often have multiple groups and multiple teams with dedicated experience and dedicated knowledge to work on. So typically you have an IP team that manages the IP network and you have an optical team that manages the optical network. Especially with bigger operators, for example, that is the case. And when, for example, an IP guy starts investigating an issue in the network, he might find not what the root cause is. And at a certain point, when they don't have any idea what to do next, they drop it over the wall and give it to the optical colleagues to see if there's something wrong in the optical network. Especially true with bigger operators. With smaller operators, it could be that it's one and the same guy that is first investigating the IP part of the network and will then go on and look into the optical side of the network. But typically still also with different tools, dedicated tools for the IP side, dedicated tools for the optical side. So in either case, a better coordination between the IP layer and the optical layer is really mandatory in order to come to a more efficient way of working and to do troubleshooting inside the network. So that's the aspiration of IP optical coordination. So if you look at what IP optical coordination will bring, it aspires to bring a full visualization of the IP and the optical layer, as well as a better information sharing from the optical layer to the IP layer to troubleshoot your network or to optimize your network. Some of the use cases that are aspired by IP optical coordination could be, for example, topology discovery. As I said, showing both your IP optical topology, your IP and optical topology in a single view. Diversity analysis, making sure that all your services are truly diverse and truly disjoint. Another example could be coordinated assurance and troubleshooting. When you do fault investigation, providing better means in order to find and locate the faults. Elastic IP optical bandwidth. In case of scheduled bandwidth needs that are higher or that are fluctuating, there are some capabilities there that IP optical coordination could bring to cater for that. Coordinated operations control. So when you do maintenance into your network, in the optical network, making sure that the IP side of the network is aware of that and these kind of things. Cost-effective multi-layer protection. Optical aware IP routing definitely is another interesting use case that IP optical coordination could bring, and some cross-domain connection management. Looking a bit more into some of these use cases, so topology discovery. Traditionally, operators have a very good means to discover the IP network. They have very good means to discover the optical network. But what about the cross-domain links? So the interconnections between the router ports and the client ports on the optical side. Traditionally, many operators are using so-called manual methods in order to do that. So they use some kind of Excel sheets that give a mapping of which router port 111, for example, connected to client port, whatever, on the optical side, is used typically to maintain that state, to maintain that connection state. Or any other, I would say, manual tool that can use to keep track of that. A better way to do this would be with an automated way to discover both. And with IP optical coordination, this is what could be delivered. So you could automatically discover your cross-domain links, for example, using LLDP snooping, one of the options, or using a packet counting-based mechanism to infer the connection between ports on the router and ports on the client ports on the optical side, which would mean a more broader way of being able to automatically discover that. So for sure, this is something that IP optical coordination could bring. Another part, diversity analysis. So in many cases, customers could, like I said, the IP guys could provision IP services. There could be a requirement that some of these services are completely disjoint. So they could provision, they do their due diligence on the IP side, and they could be convinced that the services could fully disjoint, or the services are fully disjoint, so happy days in that case. Going down to the optical layer and looking what's there, it could actually be that these services are running over the same cable on the optical side or the same cable duct. So they could, in action, in essence, not be diverse. So one of the capabilities that IP optical coordination could bring is a way to run an analysis on the network to see what, for the different IP servers that need to be disjoint, if they are really truly disjoint also in the optical layer. So this could be a case where some reports are generated, for example, that give you an overview of which services are truly disjoint and which ones are not. So you can further work on those and make them truly disjoint, at least the ones that are not. Coordinated assurance and troubleshooting. Looking at that, it's all about when there are issues in the network. As said in the beginning, typically with bigger operators, there's a way that there are dedicated teams looking at the IP side, dedicated teams looking at the optical side. So it could be that one of the IP guys is looking at some of the alarms in the network, trying to find the correlation of what is the root cause, and then coming up actually in a situation where, from an IP point of view, it looks okay. So they don't know what to do anymore. Where is the issue? Then it typically goes over to the optical team to investigate if there's something on the optical side. So in any case, a bit of an inefficient way of working. IP optical coordination could bring the capability to have a single pane of glass from an alarming point of view, where you have the opportunity or the capability to look at some of the IP alarms and have a smart correlation that could drill down also towards the optical layer and indicate if the root cause is in the optical layer, indicate that also towards the IP guys. Excuse me. So this is definitely a very interesting use case from an efficiency point of view in order to make the troubleshooting more efficient. Elastic IP optical bandwidth. So it could be cases, for example, where there is fluctuations or planned or scheduled fluctuations on the IP bandwidth needs for some of the services. IP optical coordination, so that could have an impact actually on the optical side as well. So one of the use cases or possible use cases for IP optical coordination is the capability in cases of need to have a scheduled automatic extension of the lags, for example, on the IP side and the optical side, in order to cater for these extra bandwidth needs at the time that it is needed in the network. Looking at coordinated operation control, for sure also an interesting use case. So, so there could be a need there to, for example, in the cases today, when there is a maintenance action or a scheduled work on the optical network, there could be an impact on the IP network, of course, because there could be IP services running over the optical links. So in that way, it's a very manual way to work together between the IP and the optical team to make sure if they plan a maintenance, for example, that the IP guys will read out the traffic paths in order to make sure that no IP services are at least impacted, or at least that for sure the backup is also not impacted. IP optical coordination could bring the capability to do a coordinated maintenance in the sense that when you put in an optical link, for example, in maintenance, it could trigger the IP layer to read out automatically the traffic paths and hence the IP services, both the primary and the backup paths, to make sure that there is no impact on the IP side, on the IP services, when there is an optical maintenance. Same thing in the other way around. If there is an optical restoration, you want to make sure that at least when the restoration is done, that then the services and the IP, the traffic paths could be rerouted to the original path as well. Optical IP routing, as I mentioned earlier, could be a case where the IP guys are provisioning IP services and they're fully convinced that they are using the lowest latency path in the network, for example, or that they are fully disjoint. So there are capabilities there that IP optical coordination could bring to actually give them the information, the SRLG information from the optical layer, provide that to the IP layer so they can use it to make some optimization decisions or some path placement decisions, for example, if they want to make sure that services are truly disjoint. Same thing with latency. It could be that from an IP point of view, you think I'm having a server that has a traffic path that is on the lowest latency path. IP optical coordination could give you the capability to give the latency from the optical domain also towards the IP domain. So it can be used, same thing for path placement and optimization decisions in the optical domain, in the IP domain. And then another use case, cross-domain connection management. Typically, if you have multiple optical domains, if you want to integrate that in a hierarchical controller or in an OSS layer, if it's domains with different vendors, it's a quite long and expensive process where you have to integrate the Norman interface from each optical domain controller into the higher layer. Using TAPI, a standard-based interface, could make this work a lot more efficient and a lot more easy and make the whole development cycle for the integration with a hierarchical controller, for example, a lot more faster. So in essence, in summary, if you see with all the use cases I've seen, there is definitely a possibility to provide a lot more better, efficient way of working when you have IP optical coordination, when there is a lot more information from the optical domain that you could provide to the IP domain to use to do optimization decisions, for example, or to do troubleshooting in the network. So in essence, for operators, it would mean a cost saving, of course, because there is a way to do a lot more optimized way of the current operation compared to the current operation. I think that's the last slide in the deck. I think that's about it. Thanks.